Hello and welcome to the Wednesday, April 18th edition of Moving Monolithic Applications to Kubernetes. Today is a special type of call. We're going to be doing a little bit of a retrospective and a review of the work that we've been doing over the past couple of months. And I'm going to give an update on some public speaking I did in Denver earlier this week that's kicking off a little bit of a series of going and talking more about this stuff on the road moving forward. Excuse me. So anyway, to start off, I guess I'll give an update, and then we can go in and do a quick retro, talk about things we've learned, things we want to share, and then how we're going to get those lessons kind of written into the repo and doctor all of that up. So my update is, hi Tim, welcome to the call. I was just mentioning how I'll be giving an update about how I went and did some public speaking on this earlier this week. So went and gave a 30-minute long presentation where we talked about this concept of like moving monolithic or legacy applications to Kubernetes. We talked about the repo and the work we've been doing, and really honed in on like these three things that we've been using to kind of evaluate whether it makes sense to move one of these monolithic repositories to Kubernetes or not. And those big things were value, what value are you getting out of doing it from moving to Kubernetes, the risk involved, how much risk and unknown variables are going to be at play, and of course the amount of time it's going to take you and your engineering team to do it. And I feel like we've kind of touched on all three of those throughout the course of the call, or these calls as well. And it was nice to kind of boil that down into a formula. So I think what I'll do there is I'll take an action item to do like a small write-up on those three things and how they kind of fit together, and maybe add them to the top level README of the repo. I don't know, what do you guys think?
Sounds good.
Cool, let me take a note real quick. Cool. Other than that, the feedback I got was great. More people said they wanted to be involved with these calls, and some of the other feedback I got was it would be nice if we could have like, I'm feeding back in somebody's speakers. Hi, welcome to the call, Doug. We're just doing a quick retro today.
Hey. Sure.
So yeah, if we could have like more disciplined input around, like we're going to do a demo this week and we're going to talk about this one thing and give an example. So I think as we pick things up after I get off the road, that'll make a lot more sense for these calls. But anyway, without further ado, I would like to brain dump as a team anything and everything that you have learned or gained or still have questions on around monolithic applications as a whole and migrating that to Kubernetes. I think a really good place to start is what I was just kind of talking about, which is it worth it? If you guys have anything in there, feel free to share.
Good question, I think. It's definitely worth it, but when, how, who, why, all of those things are considerations that need to be addressed as you embark on the journey so that you're not trying to solve for that midway through.
Yeah. And I think a lot of it is kind of like understanding what you're gaining, right? Like you get a lot for free when you move to Kubernetes. You get the whole ecosystem, you get the value of scalability, you get the resiliency of the scheduler, you get the idea and the reassurance that your applications are reproducible. But then, like just measuring and making sure that that's something that makes sense for you and your team and you're willing to invest the time into it is a good exercise to go through.
You're also projecting a lot of change, and I think it's important that the change is something that's not just tribal knowledge, but has documentation and effect that can carry on beyond those folks that are involved in the migration itself.
Yeah, absolutely. I think another thing that was interesting that we learned was the importance of containerizing your application and really understanding what's going on in the container behind the scenes. Like there was some effort that went into that. Josh, you put together the Docker file for us, but anytime you're moving a large application to Kubernetes, you have to containerize it. That usually implies making a code change as well. And if we had a larger application other than the one we've been working on in GitHub, like let's say we had user interface, breaking your code apart into multiple containers from the same code base would probably be a necessary part of this exercise.
I think it's also important to note that it's not necessarily a serial engagement, right? In order to get it to stand up initially, we did have some hacks commenting out the liveness probes and readiness probes. So we got it across the line without necessarily having each step being captured. And then following that, once it was stable, at least in that iteration, we were able to come back through and update our code base and update our manifests in order to reflect what needed to happen so that those liveness probes and readiness probes could be functional.
Right.
So I think if we had stepped through it very serially or iteratively and kind of forced that software development lifecycle as it traditionally seems for monoliths, we probably would have had more frustration, more missteps, more errors, rather than saying, there are things we are aware of within the ecosystem that are making this more challenging. Let's remove those temporarily so that we can revisit them once we have some stability in place.
Yeah, so I'm going to put in the retro the necessity of hacking and iterating on your application. Like, I think that brings up a really good point that if we were like we can't move on from this step until we've completed this in its entirety, till we feel like it's like production ready, like we would never get anything done. So we definitely had to kind of like glue the bigger pieces together as best we could. And then after like the larger machine is kind of running, then we can kind of go and dial in each part of the machine independently.
Absolutely.
That's a good one. So I would say another way of phrasing that would be a breadth-first approach at development.
Mm-hmm. One takeaway I definitely want to express gratitude around, and I think it's really a testament to the quality of community-driven development, is that there was no one defined approach that was handed down from on high. You must follow this methodology, you must use this provider, you must use this code base and this resource and this open source tooling. And collectively, we all approached it with different methods and perspectives, and yet each one added something to the mix and gave us a much healthier, robust application than if it had been, well, we absolutely have to have this meet our test criteria, and we have to have it be in a very certain paradigm for us to deploy, if that makes sense.
Yeah. I mean, I think another way of saying that would be the importance of flexibility. Mm-hmm. Right? Like, you definitely don't want to be in a situation where you're mandating parts of your application for the wrong reason. Like, you have to use this Docker image because our security team has blessed it, but then you explore the image and you fire up a container with that running that image, and you realize like, oh, it doesn't have most of the stuff I need, or it has a ton of extra stuff, and it's actually causing more problems than solving.
Right, and being able to flex and deploy a working solution onto GCP because of missing credentials on the KubeCon cluster, which in truth was recycled a couple of times. I think it is demonstrative of development environments that are often blocked because there aren't those synergies in place, right? So by being able to flex and say, hey, you know what, I know of a cluster over here where I can test this out, I was able to continue to do asynchronous work and commit that code even though it wasn't specific to the environment that had been stood up for this purpose. So that isn't always available to developers. So it is important to reflect that if you have a robust development environment, it may not match what your final production environment looks like, but the beauty of Kubernetes is that it can migrate pretty effectively.
I put the importance of having standardized environments. Okay. So we've talked about breaking our code up. We've talked about the importance of containerizing, the importance of iterating and doing a breadth-first approach to development. What about operating after the fact that this is up and running? We didn't really get a chance to dive into the monitoring aspect of running this thing in Kubernetes yet, but I still think that, like, as an engineer, that would be a big concern of mine.
Definitely think that those are next steps, and we can do an additional retrospective further down the road and see, where we stand today, what we feel we've accomplished, and milestones that we can consider completed, and then what are our priorities for the community going forward in the near term.
Okay.
Right? We've got the merge for the ingress using Contour and Cert Manager and whatnot. So we want to see that working effectively in the solution. But to your point, we want observability. We want to be able to iterate on the code base and see it effectively migrate through our environment.
Okay. So I think, and we have a bullet point later on down when I want to talk about refactoring the repo, but I think this might be a good chapter 1, which basically says, here's about I really think this is a good representation of what you're going to get in a real environment. Oh, we've kind of tested it. It's kind of working. We did it that one time. There's some documentation around it, and we've been able to get it up and running. And that's usually what you're going to be handed as a software engineer. So I think putting a finite resolution on that, capturing our lessons learned, and then starting a second chapter, which is okay, now that we've demonstrated we've got this thing working, let's actually go out and take it to the next step and go and explore things like cross-cardinal availability and observability and monitoring and alerting, and start to actually see what that's going to look like.
That's good.
Okay.
I think it is important to note that we are operating in kind of a greenfield environment in the sense that we don't have a production monolith that we can't touch or impact, right?
Yeah.
So oftentimes when this migration occurs, we're actually doing this work in parallel clusters to the monolith that may be on bare metal or on virtual machines. And it's important that we don't have network collisions or impact production or development as it stands today. So we've been able to operate very independently and move very rapidly as a result. But oftentimes in a real world scenario, there are other environments you definitely don't want to impact.
Yeah, that's a good point. Okay.
Yeah, Josh, I think that point was really, really good. I would say one thing that, I've noticed in talking with some customers about, their real world kind of Kubernetes experience, and we're talking about migrating from, something into Kubernetes, is what do I do when I have more than one application running in my cluster, and specifically more than one team that needs access to part of my cluster to run their whole deployment, software defined lifecycle, right? Mm-hmm. So I think that's a fantastic point.
Yep, in our retrospective, we should also capture access. Right, Tim brings up a great point about RBAC and pod access policies and whatnot that we would definitely want to implement. We ran into that a little bit with Helm, right, when we didn't have the appropriate cluster role binding associated with the service account that Tiller is running with.
Okay.
But we can definitely elaborate upon that to say, in the real world, do developers have the same rights and authority in certain areas of the cluster? When we have applications that are co-tenants on a cluster, do we need to be considerate of that impact as well? Those are all great points, Tim.
So this is kind of making my brain think a little bit here. It sounds like we've touched on a little bit of what we think we want to do next. We understand that we're at a kind of a good, meaningful stopping point and kind of taking a step back and capturing what we've worked on and making that so it's digestible to somebody approaching this repo for the first time is important. But it sounds like there's a bit of an architectural exercise for what's next. We know we want RBAC, and we can play with RBAC, but I think we all kind of have a fundamental understanding of what that means. I think it would be helpful if we actually had, here's our proposed RBAC plan. Here's our proposed monitoring plan. Here's our proposed pipeline. And it doesn't have to be anything super amazing or crazy off the bat, but at least starting to write these proposals, and then when we're on the call, we can actually look at implementing some of these designs. Mm-hmm. Okay, so let's go through really quick and let's just brainstorm what would be some parts of the application we would want to have a design doc for.
Definitely logging and monitoring.
Yeah. I think RBAC is one, or just user access policy.
Right.
all enterprises care about recoverability. We need to cover off on that as a whole.
So what do you mean recoverability? Like disaster?
Both how we recover our, from a higher level, the cluster, right? How we're going to recover the cluster in the event that some disaster happens. And then more importantly, what the plan is for kind of recovering our app as a part of that disaster as well, right?
Mm-hmm. Right. Do we declaratively address that within the ingress where the load balancer is sensitive to failures and can switch traffic without human intervention, right? So there's that piece of business continuity, but then also the disaster recovery. Let's say the entire data center is offline for whatever reason. Can we ship it elsewhere and stand it up in a short period of time and then do DNS redirect to recover as quickly as possible?
You've got it.
Awesome. So we have RBAC user access policy. We have recoverability and disaster recovery. What do we do in case of a failure? We have logging and monitoring. What about just mapping out the Kubernetes installations and configurations in general? What's running in our cluster? What namespace is it running in? Who has access to it? So maybe, what do we want to call that? A cluster diagram?
Yeah.
Cluster design.
This is huge. I think this is, the cluster design document is, I don't think I've really ever seen a good one before. And I feel like a lot of people kind of skip that step, but it very well could be a fabulous starting point, both internally for pitching this to other people on your team and for handing off to engineers saying, hey, this is a good starting point and what we would like for you to build out.
I know I'm getting circular, but if we can go back to the value proposition, I think once people see the value of Kubernetes and the insanely fast ability to deploy rapidly, the next request that we'll get from product, the next request we get from sales will be, when can I begin to do Canary? When can I begin to do AV and specify my mobile users and specify my desktop users and really get the power in place of this cluster? And so to do that, we need to have defined deployments and defined routes. So whether that's service discovery or whether that's something that we are codifying ourselves, definitely something that we can investigate and value.
Okay. Any notes? Bear with me. What about, I'm going to say it because I feel like this is like, as long as you have Kubernetes in this thing, your IT team is unstoppable. And that thing is CI/CD.
So we have a little bit of that as far as the image builder in our original code base, but it certainly is very manual. So it'd be worth it to, collectively decide on what CI/CD to approach, or if we want to simply hack it ourselves.
Yeah, I mean, I definitely think less is more here. And I think even having probably one or more ideas of stuff we could do or like approaches we've even tried might be helpful.
Mm-hmm. We also have not discussed the four-letter word very much, but test.
Well, that's okay. So there's a lot that the word test can imply, which is like everything from, infrastructure testing that our infrastructure we're running on is sane, to cluster conformance, to cluster E2E that the Kubernetes components themselves are working as expected, to your application, to the entire thing as a whole integration style testing. So there's like 5 layers of testing there.
Right, and it integrates very well with the CI/CD discussion because as much of that as can be automated, the better for everyone involved, right?
Yeah.
And are those testing environments ephemeral? Are we spinning up ephemeral clusters just for that sole purpose of deploying that test once the test is complete, we nuke the cluster so that we're not being billed into perpetuity for something that isn't used constantly?
Yeah.
Or is that something that is in a namespace somewhere and just consuming resources briefly for the test period? I'm a huge fan of the former. I say let's, spin it up in a vacuum, make sure that the tests run as effectively as possible, but don't have an impact elsewhere. Consume your persistent resources. And some providers are better at giving the opportunity to do ephemeral clusters than others, but it's something we can investigate.
Totally. Okay. Service meshes.
Mm-hmm.
We gain a lot by running like a service mesh style tool alongside of our pods. That kind of falls into the logging and monitoring bucket, but I might put that in its own bucket and call that observability. Okay. Interesting. Any other large?
I was going to say, back within test, we have load, right? How does our application handle demand? Now, the application itself in question was written to choke under large load, but how do we tune any of our monoliths appropriately so that the value that we're bringing in with auto-scaling and self-healing systems is something that isn't defeating us over time, right? That the health checks are actually bringing our application down when they shouldn't be.
Yeah.
So if we are doing effective load tests, we know that our application in production can handle bursts or plateaus that we hadn't predicted.
Yeah. Any other large areas we're missing here that you guys can think of?
I think we all think about it like inherently with everything that we do, but maybe it deserves a call out. Security constructs based around our application as a whole. We're all thinking it, so we'll let ourselves off the hook there, right? But we need to have a call out for security as a whole.
Well, and one of the things that I even earlier this week giving this talk, I mentioned security, and I had somebody come up to me and they're like, "I thought we got that for free," and I'm like,
No.
You can configure it, but you still need to learn it. But it was kind of like the bigger lesson there that was more important was people assumed that they kind of got stuff for free just by moving to Kubernetes, just by saying, yes, Kubernetes has security policies, therefore you can configure them. Some people hear Kubernetes will secure your stuff for you automatically.
Yeah, battery's not included, right?
Exactly. And I think that same lesson goes across the board, not just for security, which is just because we have a deployment doesn't mean that it's going to be configured correctly and that the scheduler is going to do what you want it to do when something goes wrong.
Yeah.
Cool. So I think the lesson there is you still need to concern yourself with security and learn it and not make the same mistakes some of these other people have made, regardless of if you're running in Kubernetes or not.
Yep.
Okay.
As long as we're all root, right? We're fine.
Yeah, as long as we're all the same with root.
Yeah.
Yeah. Okay, so congratulations, we just created the 12 factors of Kubernetes. I think these are a good starting point. In my mind, I'm kind of seeing part of the repository that's got, design docs or proposals or whatever. And then in there we have folders for each one of these larger bullet points in the Google Doc here. RBAC recoverability, logging and monitoring, cluster design, whatever. And then we can just start to put proposals in there about, concrete suggestions of how we would want to try to solve some of these problems for our particular cluster that we're building out. And then we can start to implement those, either wiki script them in our free time, do it on the call, a little bit of both, whatever. And I think moving from, okay, we've engineered the application and getting the application running in some Kubernetes cluster, I think we need to pull back and go up a level and say, okay, now let's talk cluster as a whole. And let's say, okay, do we even want to use Kubicorn to install our cluster, or do we want to use GKE, and what does that look like? So I think we can start to call out some of those in the cluster design proposals.
Mm-hmm.
Okay. I'm happy to kind of flesh out the repository structure and create some GitHub issues around this that people can pull off. And then we can even maybe look at writing some of these together if we want. Any more thoughts there? Any large areas that we're missing? Questions or comments?
I'm not sure if this is maybe a cluster design question, but what about upgradability of the cluster or patchability or the approach to it even? Do we stand up a new cluster when it's time to go from Kubernetes 1.8 to 1.9, or do we upgrade in place?
That's such a great question. And I guess that kind of like begs the next question, which is, what is the cluster design doc? Is that the definition of what's inside the cluster, or is that the definition of how to manage the cluster as a whole? Because I think there's probably two different design docs there. There's the infrastructure, the actual cluster design doc, and then there's the, okay, now that we have a cluster, what goes inside of it?
Cluster lifecycle doc. Yeah, absolutely.
Yeah, really great point.
That's a fantastic point, Doug, because if you're encountering a customer or a company that is interested in Kubernetes, it's very likely they have a cluster that's up and running that is just another pet. It isn't something that is upgradable to any extent. Someone has basically built it using the hard way, instructions, and yet it has become an important part of their ecosystem. So what is the appropriate way to do sunsetting of an existing cluster and then give a manageable, upgradable solution to replace that? Not just moving monoliths to the application, but replacing sort of the pets that originally should have been cattle. Many times we don't think of the nodes of the cluster itself as something that could be a limiting factor. But the moment they become brittle and are not able to move past 1.4 or 1.5, for instance, right? A lot of folks are running into that etcd certificate issue, where if you deployed your cluster a year ago, that certificate is now failing and your cluster is not accessible at the API. So definitely a good point.
But upgrades are a part of that broader design, but it's still the $1 million question, which is, how are we going to handle that? So,
and the more that we focus on Tim's disaster recovery model, the more that we can simply lift everything out of our old cluster and deploy it into a brand new fresh cluster and not try to approach upgrades, right? We don't have, we're not beholden to these nodes lasting forever. And the shorter the life cycle of the cluster, the less upgrade and less maintenance that's necessary, right? But we absolutely have to be able to pull everything, every manifest, every object out of the original cluster and migrate it successfully to the new one.
Yeah, that's where our
it's an interesting observation that a well-planned disaster recovery plan can be the same as the upgrade plan, and so you're kind of pruning it out at every upgrade of the cluster. That's a really interesting insight.
Well, and this is what Netflix does. And if you read the case study in the book I wrote with Justin, one of their big things is that you should be constantly breaking your production systems just to ensure that they're working as expected. And once you get good at breaking something, you realize that you're actually getting good at just repeating something.
Which is a fascinating tangent we should look at within this, and that is how to address the fear of production, right? Production is just another cluster at this point. But it seems like once an application, once an infrastructure has had that production label on, well, only one or two people in your organization can touch it, and don't ever actually make changes because, oh my goodness, it's prod, right? And I think you're right. I think Netflix and some other companies really address that well, where production is just another step in the life cycle, right? And it should be treated like everything else, as ephemeral as everything else. The moment we consider it permanent, the moment it becomes more important than itself.
Absolutely. I think fear of production is the big takeaway there. What do we do? And even calling out that that's a thing and making people aware that they need to kind of watch out for that, I think is going to be helpful.
Mm-hmm.
This is good. So we have two main sections here. We have just the retro lessons we've learned in the first preliminary process of getting the application running in some cluster. And we have a little bit of like an idea for what we should do now with actually going and orchestrating clusters as a whole, and understanding the broader scope of work here. And I think we're going to end up applying that same philosophy we did with our application to the cluster, which is to kind of take a breadth first swoop at this. And then after we have that done, we can kind of iterate on it some. Cool. I'm okay to move on. Do you guys have any other thoughts or questions there?
I'm good.
Cool. Let's see. Go all the way back up to my talk here. Okay, so I am going to be, this is just an update on the meetings in general. Pretty much all of May, I'm going to be traveling. So I'll be back June. So that gives us a month to go and flesh out some of these design proposals. And I'm going to be talking primarily about this session and the work we're doing here. So there will probably be a little bit of, let's look at our design proposals when we get back. And then also let's feed back in anything else I've learned while I've been traveling for the past month, talking about the stuff into the cycle. You know, what other questions are people having? Do we miss anything? And I'll be sanity checking this model we just kind of fleshed out in the field as well. Sound good?
Sounds good.
Cool.
Yep.
If we don't have anything else, we can take the other 30 minutes back.
Sounds good. I really think this was a valuable retrospective, and we learned what we have not been capturing going forward. So that's nice.
Yeah.
I'm glad we took the time to do this.
Yeah, I've been thinking about this for a couple of weeks. Like, if we really just need to kind of step back, I feel like we were getting off in the weeds a little bit.
Mm-hmm.
Yeah. Cool. Well, we're here as always if there's anything we can do to help. All right. Thanks, everybody.